Hi, everybody. Thanks for hanging out for test. Always, I think, the most exciting part. Yeah, I might need that. I'm going to give you an overview of what's going on in TST working group. TST is responsible for testing, open source collaboration for testing, and also POCs or experimentation. These slides were largely built, you'll see that I'll talk a lot about the plug test, but the technical portion of the plug test and these slides were all in the report done afterward and built by Sylvia, who's hiding in the back, so I want to acknowledge her. My name is Pierre and I'm from Keysight. So what I'll go through today is the plug tests that happened in May and June of this year. I'll go through the organization of it and what was special about it and the results, and then the test working group activities right now as well. So first and foremost, hold on, let's get the green working here. Plug test. It was, again, a really successful event. 45 plus different implementations were being under test. And we had a lot of open source support, again, and it even increased this time around. So our best friends from OSM were there as always, like Paul had talked about earlier. OpenStack, the supporting organization as well. Open Baton, and then we had two new ones, Sonata from 5G Tango, and also Open Air Interface that took part in the plug test as well. What was a little bit more special this time is that OPNFV held their Plugfest at the same time, same location. So it was a co-located Plugfest for the first time. OPNFV, for those who are not that familiar with it, thanks, countdown. It stands for Open Platform for NFV. It's a Linux Foundation community that was founded, I think, about 4 years ago. What they focus on they're a little bit different than most open source communities. They're an integration community where they take various products from open source communities across the gamut of NFV, integrate them and package them as a reference platform. But what's cool about that is that they become very sophisticated about the testing of that, and you'll see why now. So the plug test is an event, it's a 2-week event, the event itself, the last week of May and 1st of June, but it lasts over several months. The organization started, I think, in March. The pre-testing, which is a really, really important phase of this, lasted for a couple of months, actually. And how is that done? The plug test itself was held for 2 weeks. The second week is where OPNFV crowd joined us, and they held their events as well. Now, OPNFV, their Plugfest actually is 2 parts. They actually do sit there and hack things together and try to develop stuff, but it's also a ton of project meetings that go on the side. So they actually had about 3 or 4 parallel tracks completely full of their own project meetings going on at the Etsy premises in Sophia Antipolis. What enables the remote testing, and in fact the plug test itself, is Hive, and I always forget what it stands for, but it's an infrastructure hosted by Etsy that allows remote connections for multiple labs. So participants, the platforms could be remote, the VNFs could be remote, the Manos could be remote, all connected together through Hive. OSM has its own Hive interconnected with the Etsy Hive, and that's how they brought their solutions into the plug test as well. And for those who are old-fashioned, you could actually bring your hardware and software on site. This gives an interesting looking map. We had about 46 different sites worldwide connected through Hive during the plug test. So most of the people, most of the companies and the communities had their labs, had their software, had their hardware remotely. Okay. Now, the test sessions, what were they? We kept the same principle as we have in the past 2, this is the 3rd plug test, where there's 3 components to be looked at. So the platform itself, what we call, it's the NFVI plus Vim, so we're kind of violating the architecture. We're calling that the platform. So it's the hardware virtualization layer, and also the Vim is considered one thing, one interop thing, if you will. The Mano, which we reduced to the orchestrator and VNFM, is another component, and then the VNFs. The focus this time around, we always try to push things forward as much as we can for these plug tests, is the focus was entirely on multi-vendor network services. So multiple VNFs strung together to form one service and then do some of the testing that way. The focus of this presentation will be on those results as well. Having said that, there are also some other tests that people could attempt, and those results are in the report. I'm not going to bring them up in this presentation now. But things like single VNF network service, the basic, that was all done through the pre-testing. The pre-testing is mainly there to make sure that everything works when people get on site, so you're not wrestling with onboarding, et cetera. The basics are already in place. But advanced testing, like enhanced platform awareness, multi-site was tested as well. Specific ENF M's were made available, but still not tested. Scale to a level, which was brand new test cases. Forwarding graphs, SFC, automatic lifecycle validation, were all optional-ish kind of tests that people could get to if they had a chance, but the focus was definitely on multi-vendor network services. There was also, this one grew exponentially this time. We had started in Plugtest 2, but API testing. So now that the soul specs are coming out and the open API machine-readable files are starting to become available, we're starting a road towards API conformance testing as well. So a plug test typically is an interop event, but in this case, this was conformance testing of the brand new APIs. So it uses a mechanism called Postman, and it was looking at SOL 2, 3, and 5 for that. The systems under test there's 4 of them shown there, but it's largely just a test system and the system under test, depending on what that system was for each of the various APIs. A lot of people participated. So we had 9 platforms, and again, platform is NFVI plus Vim. You'll notice there's a few of them are there multiple times because they would come in with various hardware vendors, et cetera, with the same software running over top. You'll notice in the right column, every single one of them was OpenStack based. The 2 OPNFV. OPNFV brings in OpenStack as part of its integration platform. Manos came in even bigger than before, so we had 10 different implementations of the Mano stack. Mano, again, being orchestrator plus manager only. So we had people from various companies, including some open source ones as well, which is kind of cool. We had open source a little bit represented in all the different categories. And VNFs were a lot. So this is cool. We had this enabled OPNFV to finally do some testing over commercial VNFs, and that gave them an opportunity to do a lot of different things as well. You'll notice some companies again listed there a few times, mainly testing companies, because they had either different test units, et cetera, et cetera. So, but there's at least I would call it about 15 different VNFs doing all sorts of different things, everything from load balancers to firewalls to EPC, and we had an open source EPC as well. So it really brought the variety of different types of applications that participated in the plug test to a new level. We documented here, I won't go through this, but I think 27 different multi-vendor network services that were tested. I think even more than that were tested. But this is just a listing of those that were officially documented test results put in. So a lot of different variations with all the companies participating were the main focus of this. And then one additional thing that happened in the plug test this time was ETSI CTI, which stands for Center for Testing and Interoperability. They said, hey, if a bunch of you want to get together and do a demo of certain neat functionality, why don't you do that? So 6 of them were organized. And there were some pretty cool things there. They're either network service orchestration, service assurance, a 4G network orchestration, and very cool stuff like VNFD validation was brought into play as well. So a lot of different very cool things were demonstrated as a part of the plug test, so it would allow everybody to see, hey, this is what's going on. Now, this is the part that's dear to my heart because of the co-location, this allowed us to get together with the OPNFV crowd and see how we can move forward and collaborate. So there's the 2 on the left I'll talk about a little bit later, but the ones on the right, specifically, so OPNFV has a program called OVP, OPNFV Validation Program. Basically, it's a set of conformance tests to get a stamp saying this is OPNFV valid. The tool that executes that is called Dovetail. It's also the project. Well, this enabled Dovetail to come in, participate, and run their platform validation over commercial platforms for the first time. They would run it always over open source platforms at OPNFV. So this gave them a lot of stuff to learn and see how it works, how portable that tool is, and that program can be, which is an ambition of OPNFV. By the way, they're going to bring in ONAP into this verification program soon. OSM was there, and they got to talk to OPNFV. OPNFV has a really sophisticated project called XCI, Cross Community CI, where they actually pull in the master branch code from multiple other open source communities like Open Daylight, OpenStack, Fido. There's 2 more, I always forget them. It's not Panda, anyway, there's a few more. But this time they got together with the OSM community and said, hey, pulling in a Mano stack would sound pretty cool. And they got together, and within the week, they got it working. So now OSM is part of the community for cross-community CI. They get their code pulled into OPNFV and tested. And OPNFV has this huge CI pipeline, very sophisticated. They test it, and they'll shoot back bugs to those communities when they're found. And in fact, it's getting to the point where even OpenStack is starting to rely on this mechanism because we're doing a lot of testing in OPNFV that they can't do. They don't have all the platforms that OPNFV has. So everybody loves this. And the fact that OSM is now part of it is also beneficial to both communities as they interact. And then the next one, SFC testing. SFC is a project at OPNFV that basically enables service function chaining, specifically using the NSH protocol developed by IETF. It's bleeding edge stuff. It's an upstream, it belongs in OPNFV, but it's an upstream project they developed with ODL, Open Daylight. But now that OSM is part of OPNFV, 2 things happened. They said, oh, cool, we can use this Mano stack to drive our SFC, which they wanted. And then secondly, it allowed them to test against, it happened to be a beta version, but of a commercial VNF that did support SFC. Not a ton of them do. The tests were about 50% successful, but it's actually ongoing. They got so interested in being able to try this out on both sides, the commercial VNF vendor and the SFC project, that it's actually still ongoing, and they're going to get it right. All right, hold on, next. Highlights of the results. Okay, I'll start getting into results now. First of all, this is very high level. The first lesson is more test cases were run. More test cases were run, but in fewer sessions. The sessions were longer, but we were able to do more testing as a result. Okay, the graph on the top right shows that. So the actual line shows the sessions, so it's a decrease in sessions, not in results and test cases. More test cases were run, and the success rate, interop success rate, actually ended up being slightly higher than the last plug test held in January. So it is progress. The API testing, again, grew exponentially. There are a lot more test cases, a lot more people were trying it out, and the success rate grew as well. So the amount of test cases run that were available grew, and people were really getting into it. And that's natural because the Sol specs and the Sol APIs are just coming into existence for the past few months. People need a chance to implement them. And then the last thing is something new, well, newish. It was tried in the second Plugfest plug test, but the third one had a whole lot more automated testing because one company showed up with a tool that was able to automate a lot of this. So a lot of the testing has been able to grow in automation, which is a goal always. So progress was made on all 3 fronts. The overall results, there was a total of 1,400 test cases. How to interpret this table is a little, you need to know. So the interoperability test cases, so the 2 columns, okay and no, so green and red, was what actually was attempted. The gray column, NA, was actually not attempted. And a test case is not attempted if one of the multi-vendors does not support a specific feature for that test case, or mostly they ran out of time. They couldn't do it, okay? So what you look for mainly, I think anyways, is the okay and no. And this guy here, top right, shows total execution rate, if you will. So just over 55% of the test cases were attempted, and of those, close to 90% success rate. So this is pretty good. This is getting better and better. We are improving over plug test 1 and plug test 2. For the API testing, 25% of the test cases were not attempted, but when they were, it was a success rate of about 70% overall across all the features. I'm not going to dwell on this, there's too much information in there, but these were the test cases, the subgroups of test cases for the multi-vendor network services. The highlights there, this is straight copy and paste from the report, by the way. But the highlights is, you know, the basic stuff we're getting. We're almost at 100% almost everywhere. A little bit of work needs to be done in scaling VNFs based on Vim KPIs. So the Vim telling the manager to scale the VNF, please. Not there yet. Other types of scaling are improving drastically. Okay. On the API, you'll see that a lot more test cases were run on Sol 3. It was the first one available. Everybody attacked that one first, so it's between the orchestrator and the manager. And the success rate was pretty good as well, so 75%. For the rest of them, the last two, Sol 3 package management and grant, nobody tried anything. But the others, the success rates were about 50 to 60%. Okay, which makes sense given the early stage of the implementations based on these specifications. One of the big goals, you know, there's multiple goals for interoperability events like this. Obviously to tell yourself how well you're doing with your product, your whatever, but also for us. This is feedback back to these guys here. Okay, so the best way to find out how specs are doing, how implementations can match them, is to test everything and then feed it back. So there's a lot of feedback back into the solutions working group, general feedback and then specific feedback on the 3 specs that have been tested, Sol 2, 3, and 5. Mainly relating to, oh, there's a typo here and there, but mainly relating to interpretation. How do you interpret these specs? And there's a little bit of confusion here and there, and people are asking for more clarity. But that, I think in the general sense, that's mainly what it is. There was also feedback on the APIs themselves. Now the API test, like Solutions Working Group, not only built the documents, but they built the open APIs. And 15 bugs were found there, so that's fantastic. And that's about as fast feedback as you can get on specs, because these guys have been available only for the past few months. So 15 bugs were found, already fixed. And also a few other suggestions based on interpretation and the ability to use a null value. Feedback to us, to the test working group, because we produce specs on interoperability and API conformance as well. So what happened here is the plug test, Sylvia and the team, they build a full test plan that's publicly available. This will, not that one, but there's a live link somewhere in this presentation. They go forward with the test plan, and then they modify certain things. Either they find bugs or they need to modify things given reality, and then feed it back to us. So basically, we've received, this points to a contribution, a list of test cases that have been modified or should be added to the work item in our work group called Test 7, Test 007, which is the Mano interoperability spec. So we've got a lot of feedback for that. And also, because there's an API test track going on, there's going to be learnings from that will go into the Mano API conformance test plan as well, and STF, and I'll go into that a little bit more details later on. There are 2 reports available for this. The major plug test report, which is a big thing that is done by Etsy, and then also, and that has all the details about the Etsy NFV plug test portion of this. But then there was also a joint report that was built between ETSI-NFV and OP-NFV themselves. So both of them are available. I think the plug test report has been available since early September. The joint report has been available for about 2 weeks. All live links, by the way. What's next? Well, ETSI-CTI will conduct remote testing, mostly focused on APIs, for 2 months, February and March. So people that are connected through Hive will be able to sit there and try either conformance, I'm assuming, conformance testing against Michele's Postman stuff, or maybe even interop sessions as well. It'll be based on SOL 2, 3, and 5. And the next plug test, number 4, is already scheduled. So the first-ish week of June, first full week of June, will be the next plug test event. So this will give people plenty of time to move along with their implementations and bring them about. And there's probably going to be more focus on standardized interop as was before. We've also, the very initial discussions with Linux Foundation Networking, LFN, to bring OP-NFV back, again, to co-locate their plug test, hopefully. Pierre crosses his fingers as always. And this time they would consider bringing ONAP into this. So that would make it a real fun deal. So what are we doing in 10 minutes or less? I'm going to dwell on this one. We've just officially approved a test spec that's actually a spec and not a report. We rarely do that. But this is a big one, and I like to promote it a little bit because it's called Test 009, and it's all about network benchmarking and methods for an FVI platform. So if you've ever done benchmarking and performance testing on telecommunication systems, you've heard about RFC 2544. It's the standard. That's the one that tells you how you go about benchmarking the performance. But like the rapporteur said when he introduced this concept to us, RFC 2544 is old enough to drive a car and buy a beer at the bar, in an American bar. It's old. It needs an update. And that's what we did. The rapporteur here is Al Morton, who happens to also be the benchmarking working group chair at IETF. This guy's good. We went forward and updated RFC 2544 given the new reality of shared platforms that it never took into account. So it defines benchmarks, it defines test setups, test tool requirements, and also methods of measurement for performance, network performance of the NFVI. So the benchmarks, there's 4. They're pretty normal stuff. They're just defined a little bit more rigid fashion, I'd say. But it's throughput, latency, packet delay variation, and loss. For each of the benchmarks, the column on the right, that is defined for. So I've got an example. For instance, throughput has parameters that you input into it for the metric, such as offered load frame size, the step size, trial repetition. So these are testing parameters on how you get there. Okay, so it's a pretty extensive definition. There's also things like scope. What are you measuring? One CPU, a full platform, a virtual CPU, etc. Units of measure, definition, the sources of error, and even the reporting format is defined for each of the benchmarks. Now, it also has, for the methodology, it looks at platforms with various, a lot of variations of platforms, meaning, if we start top left, this is the most basic stuff, what we call phi to phi. So there's no VM, it's just through the vSwitch and back. You can have a VM there, so they call that PVP, physical, virtual, physical. Or you can have 2 VMs with a vSwitch in the middle, so PVVP. And I'll skip to the full right. There's also bypass technologies that's taken into account, meaning SRIOV. And for those that were questioning earlier, it's also applicable to containers. So container to container networking or pod to pod. Okay, this should be applicable to any type of configuration you have. The test methods is broken down, and the whole methodology is broken down like this, where you have a method. The method is where, okay, I'm going to try a certain packet size and see what the goal is and what the maximum performance is, which breaks into a set of tests. The tests have multiple trials. So a test is basically, okay, I'm going to try at 2 packets per second. It works. Go to 4, go to 6, etc. Every one of those is a trial. Together, once you reach the goal, is one test. But how you get there is typically through a search algorithm, and I'll talk about that a little bit more as well. But the first thing is what we found, and especially at OPNFV, is performance tests on a virtualized platform were really, really hard to repeat and get the same results. Because the binary search would go on and on and on, and whoop, stop at a certain level, and then they run the test again, and they get double performance. And then it would just be all over the map. And people were trying to find out why. Why is that? And what they came up with is basically, typically, in the physical world, what you're trying to figure out is resource exhaustion, is when is your NFBI at max, and that's your maximum performance. But we found that there's other processes, it's a shared platform, that we are calling transient processes that would skew the results. So you would have a test, and you would go, is the resource limit exceeded? No. But was there an error? Yes. So the result would turn into a negative, which is what Al calls a false lie. And it's actually into this reference right here. So the goal was to mitigate that. And it's because of the nature of the platform that you would experience loss because of transient processes. So what we did is we backed up and said, okay, let's separate the two problems. Let's find that resource exhaustion, and then let's find the transients and treat them separately because they should be dealt with separately. But don't let transients screw up your performance numbers. So they came up with this binary search, which has existed forever, with loss verification. So it spends time and basically what it says is separate the resource exhaustion and loss due to transient, and then if a trial fails, so if I try a test, a trial, and it goes 100 megabits per second, and it fails, the simple concept is try it again for a maximum of 2 times. Okay, and if you get a better result, then keep marching on. And you'll find that the resource exhaustion limit is far higher than that first failure. Okay, and the way to do, one of the ways to do it is basically, first thing, if you lose too many packets, all bets are off. Okay, this isn't working, you're done. So you try it again at the same stimulus, but you keep the trials short in order to avoid the transients. So that's what that graph. So the first trial in red, there was a blip, and then it failed. So you try it again, and you didn't get the blip, then you move on. We're not ignoring it. We're not giving virtual platforms a free pass because they're virtual, and we'll say we're accepting packet loss is a good thing. We're not. That's what my guys said back home when I introduced. They said, what do you mean? It's a loss. Who cares? And they're right. But what you want to do is isolate the two problems. And then once you've isolated transients, you've found your resource exhaustion, then you run long duration tests to find out the frequency and the impact of those transients, which you can address totally separately. And then you come up with a better result, okay? I hope that makes sense. It's an important document, I find, anyways. And the coolest thing is, I think we've demonstrated the best way to work with open source because we went into an iterative fashion. We involved OPNFV right from the beginning. All the test projects, they were commenting into this. And more importantly, 2 of the projects, VSPerf and NFV Bench, were implementing this as we were going along. And they corrected us. And we had literally an agile process of immediate implementation and feedback, iteratively going through this spec until we came with a satisfactory result. So I'm kind of Proud of that. To me, that's the way. It's an agile process, immediate implementation, fail, fast, correct, try again. So it was a great collaboration. Moving on, yeah. Test 10 is going to become very, very important. This is the one that will, it's a conformance test suite for the SOL APIs, so Mano APIs. It's just starting. We don't have a ton of things to show yet, but it's fully into progress. This is such an important work item that Etsy gave us a budget to hire 3 experts to help us implement it. And it's not just a document, it will be a fully automatable test suite. We've selected Robot for that, which is it's an open source community, very active open source community, that it will act as our framework for all the tests, and it'll be able to plug into all types of architectures and run as soon as you get it. Again, here, we're trying to collaborate with OPNFV. There's a potential that the OPNFV Func Test project will integrate this and automate it for us. And then as next steps later on, they might even give us an instrumented platform so that we can fully automate tests like notifications. Very important work item. Next one, I'm going to have to race now. I got 30 seconds. Test 11 has started about 4 or 5 months ago, and this one will define an abstract test domain and requirements for a test domain language to go along with it. The point being trying to automate everything about NFV testing by following this type of model. There's an illustration there. The draft 3, this is in draft form, so is test 10 obviously. Draft 3 is available, draft 4 should be available in a few weeks. I invite you to take a look at it. It's really abstract, but once you pull back and start looking at it, it starts making a lot of sense as to how we could have a portable, automatable test system for NFV. And last but not least, this one is such a baby that it doesn't even have a cover page. I couldn't put it in there, but test 12 just got approved 3 weeks ago. And this one will look at NFVI and Vim control and management plane performance. So look at things like how fast can you stand up a VM? How fast can you migrate a VM? How fast can you scale? Just control plane performance. Now this one's really delicate. It's difficult. But because a lot of stuff depends on DNS themselves. So we're going to take a good look at it, and we figure it's a great way to educate the industry on what's good and what's bad instead of everybody shooting off into different directions. And that's it. 1 minute over. I'm doing pretty good. I lost 5.